morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this session, I would like to discuss about problem on strength of a riveted joints. So, already we have discussed in the previous sessions. So, the riveted joints, introduction to riveted joints, and what are the failures of riveted joints, and how to calculate the strength of the riveted joints. The empirical relations we have seen. So, in this today's session, we will solve one problem on strength of a riveted joint. So, take this problem. See, here given a double riveted lap joint. So, type of joint is double riveted lap joint. Already you know the types of joints on the single riveted lap joint and a double riveted lap joint. It is made between 15 mm thick plate. The thickness of the plates are 15 mm. The thickness of the plates 15 mm, given that is T, small t. The rivet diameter and pitch are 25 mm and 75 mm given. 25 mm and 75 mm. So rivet diameter D, small d, that is 25, and P is 75. If the ultimate tensile stresses are 400 megapascal in tension ultimate tensile stress, not permissible shear stress. He has given here ultimate tensile stress. You need to calculate permissible tensile stress. And similarly 320 megapascal in shear and 640 megapascal in crushing. Sigma T, sigma U, ultimate tensile stress, and sigma S, so sigma UT, so ultimate tensile stress, similarly sigma S and sigma C. So he has asked to find the minimum force for pitch, which will rupture the joint. So find the minimum force. If the above joint is subjected to load such that a factor of safety is 4, a given factor of safety 4. So already you know the factor of safety definition. So it is a safe factor to avoid the failures. You need to take factor of safety while designing any component. So here also apply this factor of safety for calculating permissible tensile stress, that is the permissible working stress, that is actual stress, or also called as design stress. Factor of safety is equal to ultimate stress by maximum stress by working stress. So find out the actual stresses developed in the plates and the rivets. So first calculate the minimum force for pitch, and then calculate when the above joint is subjected to load, so that factor of safety 4, and also calculate the actual stresses. So the solution we will see. So first of all, write down the given data. So given T is 15 mm, small d is 25 mm, and P is 75, and sigma T, tensile, ultimate tensile 400 megapascal, you can convert into Newton per mm square. The similarly shear ultimate 320 and compressive 640. So first calculate minimum force for pitch, which will rupture the joint. Clear? So since the ultimate stresses are given, therefore we shall find the ultimate values of a resistance of the joint. Clear? We know that the ultimate tearing resistance of the plate for pitch is PTU is equal to P minus D into T into sigma U. So already we have seen, we have discussed in the failures. Failures of riveted joints, tearing across the rows. So take the empirical relation P minus D into T, that is the pitch length P minus D into T thickness and the ultimate tensile stress. So substitute the given values, you will get 300,000 newtons. Similarly, ultimate shearing resistance of the rivets per pitch. Ultimate shearing resistance. So calculate by using this relation and multiply with 5 by 4 into d square into ultimate shear. So area and area of the rivet multiply with shear. So the area of the rivet is equal to 5 by 4 into d square. Why? Because it is a circular cross section, a rounded bar. So d is the diameter of the rivet. Here n number of rivets. Here given joint is double riveted lap joint. So that's why the number of rivets is 2. So multiply with 2, you will get shear resistance, ultimate shearing resistance. Similarly, calculate ultimate crushing resistance. The crushing resistance of the rivet. So what is the empirical relation? Crushing area multiply with the ultimate crushing strength. So it gives crushing resistance of the rivets per pitch. So what is the area? Crushing area? D into T. So and here number of rivets are 2. Multiply with 2. We will get crushing resistance of the rivets per pitch is 480,000 Newton. Or you can write here 300 kilonewton. Similarly, this one 314.2 kilonewton and 300 kilonewton. Sorry, 480 kilonewton. So from above values, we see that the minimum force per pitch, which will rupture the joint, is the minimum force is 300 kilonewton. He has asked what is the minimum force, so which will rupture the joint. So that is 300 kilonewtons. So like this, how to solve this type of the problems. The first part is completed. The minimum force per pitch, which will rupture the joint. The second one is he has asked actual stresses produced in the plate when it is subjected to load with factor of safety is 4. So therefore, first calculate the safe load per pitch length of the joint. So here load is 300 kilonewtons. The safe load is 300 kilonewtons by 4. So it gives the actual load or safe load. So that is 75,000 Newton. So let's take ultimate tensile and shear and crushing with the actual tearing, shearing and crushing stresses produced with a safe load of about safe load in tearing and shearing and crushing. Clear. First calculate the actual tearing resistance of the plate. So that is PTA, actual resisting force. So that is so take this 75,000. This is safe load and is equal to area, tearing area multiply with resistance, shearing, actual tensile stress. So in previous case, I have taken ultimate tensile stress, but in this case, he has asked the actual stress. So that's why here we don't know this actual tensile stress. We need to calculate. So that's why this value is unknown. Clear? All remaining values are known values. So substitute those values in this equation. You will get the actual tearing strength, tearing resistance, steering stress. So that is 100 megapascal. Similarly, calculate the actual shearing resistance. So by using this empirical relation, the shearing occurred for double riveted joint is n multiplied with shearing area. Similarly, the actual crushing resistance. So here crushing area multiply with crushing strength, the actual crushing strength. So calculate the actual crushing strength. So finally we'll get 100 megapascal. So here we can say the minimum actual stress is 76.4 megapascal. So like this, to calculate this type of problems, so strength of a riveted joints. If you know the strength of riveted joints, you can calculate the efficiency of a riveted joint. So this is the problem given. So find the efficiency of the following riveted joint. So here given riveted joint is single riveted lap joint of 6 mm plate. The thickness of the plate is 6 mm. 6 mm plates with 20 mm diameter. The diameter is 20 mm. The thickness is 6 mm and the diameter is 20 mm. So the rivets are having a pitch of 50 mm. The pitch is 50 mm. So second one is double riveted lap joint of 6 mm plate. The second case. So here given the type of joint is double riveted lap joint. The dimensions of the plates are 6 mm with 20 mm same dimensions, and rivets having a pitch of 65. Here pitch value is different. The previous case single riveted lap joint, the pitch is 50 mm. In second case 65 mm. So here given some assumptions, assume permissible tensile stress in plate is 120 megapascal. Permissible shearing stress in rivets is 90 megapascal. Permissible crushing stress in rivets is 180 megapascal. So here given permissible tensile stress. So by using this data, how to calculate, to determine the efficiency of the riveted joints for single riveted lap joint and double riveted lap joint. So how to calculate the efficiency, you will see. So first of all, write down the given data, thickness and D, diameter of the rivet, and sigma T, the permissible tensile stress 120 megapascal. So convert into mm square, Newton per mm square. So and shear stress 90 megapascal, 90 Newton per mm square. Sigma C is 180 megapascal, 180 Newton per mm square. So calculate here first efficiency of the first joint. The first joint is lap joint. So the pitch is 50 mm. The lap joint pitch is 50 mm given. So first of all, so let us find the tearing resistance of the plate. And next shearing and then crushing resistance of the rivets. So already we know so how to calculate this tearing resistance of the plate across the edge and across the rows, and the crushing and shearing. So apply those empirical relations and calculate the tearing resistance of the plate and shearing resistance and crushing resistance of the rivet. And then we can substitute these values in efficiency empirical relation. So first of all, calculate tearing resistance of the plate. So the tearing resistance of the plate per pitch length. So here, so always we will consider tearing resistance for pitch length only. Clear? So here the tearing resistance is equal to P minus D into T into sigma T. So the P minus D it gives pitch length, and multiply with T it gives area, the tear area. Clear? So here 50 is pitch value and D is the diameter of the rivet, 20 mm given. Clear? And the thickness of the plate is 6 mm multiply with 120. So that is permissible tensile strength. You will get the tearing resistance, that is load, 21,600 newtons. Similarly, calculate the shearing resistance of the rivet. The joint is a single rivet lap joint. Therefore, the strength of one rivet in a single shear is taken. So we know the shearing resistance of the one rivet. So that is PS is equal to 5/4 into d square into shear stress. That is ultimate shear stress. Permissible shear stress. So substitute those values in this equation. You will get shearing resistance. This shear area, the 5/4 into d square shear area, multiply with permissible shear stress. So if you don't know, if not available, so in permissible shear stress or permissible tensile or permissible crushing, so in that case, what you have to do? So calculate the permissible value, the tensile, by using this relation, ultimate stress by factor of safety. So similarly, shear stress also. Shear permissible value is shear ultimate by factor of safety. Similarly, crushing stress, ultimate stress by factor of safety. You will get permissible shear stress. But in this problem, it has given clearly the permissible tensile strength, shear strength, and crushing strength. So no need to calculate. Directly you can substitute. Next one is crushing resistance of the rivet. So in this crushing resistance, crushing area multiply with crushing stress, you will get the strength of one rivet. That is crushing resistance of one rivet will get. So here multiply D is 20 given diameter, and T is the thickness of the plates, 6 mm, and sigma C is the crushing stress. So we will get 21,600. So now the strength of the joint. So when it is, we have discussed, we have calculated when it is subjected to tear, when it is subjected to shear, when subjected to compressive crushing. But what is the final strength? The strength of the joint. The strength of the joint have to take the value of this, the least value of tensile strength and shearing strength and compressive strength. So out of these three, so which one is least? So that should be taken as strength of the joint. Clear? Here compressive crushing resistance value is lesser value when compared to others. Clear? 21,600 and 28, and here also 21. So 21,600 is the least value. So the strength of the, and next one is according to efficiency formula. So efficiency is equal to least of these strengths, PT or PC or PC. So that is strength of the joint upon the solid plate, the strength, the solid plate strength. So that is P. So solid plate means unriveted. So unriveted plate strength, that is P, is equal to pitch multiply with T multiply with sigma T. It is subjected to tensile. Clear? So this is area and multiply with sigma T. You will get solid plate strength. So here 36,000 is the solid plate length. So here already you know the pitch is 6 and T is the thickness of the plate is 6. Pitch is 50 and 6 and 120. Sigma T is 120. So we will get 36,000. So now substitute these values in efficiency relation. So we will get efficiency. So our obtained efficiency is 60%. So that's why for efficiency calculating problems, first you should calculate the strengths of the rivet, and finally decide the strength of the joint, and then apply the efficiency formula in that solid plate unriveted strength also there. Calculate unriveted plate strength and take their ratio. So you will get efficiency of the joint. So like this, need to solve this type of problems. Okay, thank you. Next one is efficiency of the second joint. So in this double riveted joint, second case is double riveted joint. Clear? The second riveted, the double riveted joint efficiency also calculate the same as the previous one. Here tearing resistance pitch, only pitch value is different here, 65. Given the tearing resistance of the plate, calculate the shearing resistance of the rivets, so crushing resistance, and then finally calculate strength of the joint, and then efficiency of the joint. You will get here 69.2% in case of double riveted lap joint. In first case 60%. So like this to calculate the efficiency of the joint problems. So these are the references I have taken. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.